It is given that the fundamental frequency of a sonometer wire of length is f0. A bridge is now introduced at a distance of delta L from the center of wire, where delta L is much less than that of L. The number of beats heard per second if both sides of the bridge are set into vibrate in their fundamental modus. So over here it is given that the fundamental frequency of a sonometer wire of length L is f0. So if you are just considering a sonometer wire of length L0, and if it is oscillating its fundamental mode of oscillation, let's say with one loop, then we can write the equation for its frequency. We know that the value of its frequency f0 will be equal to nothing but v divided by 2L. Now a bridge is now introduced at a distance of delta L from the center of wire. The number of beats heard per second if both sides of the bridge are set into vibrate in their fundamental modus. Now if you are just considering a situation that a bridge is kept in between these two fixed end, let's say somewhere over here, in such a way that it is at a distance delta L from the center, so we can write it as L0 divided by 2 plus delta L, and on this side we can write length is equal to L0 by 2 minus delta L, and these two are set into its fundamental mode of vibration. Let's say the string is vibrating something like this with different frequencies. Let's say the frequencies over here is f1, and frequency with which this is vibrating is taken as f2. So we can write the equation for this f1, which is equal to v divided by 2 into L. L is equal to L0 divided by 2 plus delta L, and the value of f2 we can take it as it is v divided by 2 into L is L0 by 2 minus delta L. Now our aim is to find out the value of this beats frequency. So beats frequency is difference in frequency. So as the value of f2 is greater than that of f1, we can go for f2 minus f1 for beats frequency. That is v divided by 2, we can take it as common, it is 1 divided by L0 by 2 minus delta L minus 1 divided by L0 divided by 2 plus delta L. Now if you are finding out the value of this beats frequency, if you are taking this L0 by 2 minus delta L into L0 by 2 plus delta L as LCM, we can write it as v divided by 2 into this delta L minus of delta L, that we can take it as 2 delta L divided by a square minus b square, that is L0 by 2 the whole square minus delta L the whole square. Now for the calculation purpose we can take this L0 by 2 as common, so it is going to be v divided by 2 into 2 times of delta L, and if you are taking this L0 divided by 2 the whole square as common, so this is going to be 1 minus delta L divided by L0 into 2 the whole square. So we can write this as equal to nothing but 4v delta L divided by L0 square into 1 divided by 1 minus 4 delta L square divided by L0 square. As the value of delta L is negligible as compared to that of L0, the value of delta L0 square is a very small value, so this term we can consider it as equal to 0. So the value of its beats frequency becomes 4v delta L divided by L0 square, which can be written as nothing but 4 into 2v divided by 2 L0 into delta L divided by L0, because our aim is to write it in terms of fundamental frequency. So that we can regress 8 into V by 2 L naught is nothing but F naught. So we can regress 8 F naught delta L divided by L naught.